Hey guys, y'all ready? All right, so it's Friday morning. Well, for y'all. Okay, so today we're dividing radicals. All right, this stuff is kind of weird, kind of like the multiplication one. It looks very straightforward at the beginning, but there are some really weird rules. And yes, you will see this again in other math classes in the future. Trust me. I help Allie sometimes with her homework. Okay, so here we go. 11.4 dividing radicals. Okay, so there's some definite rules associated with dividing radicals that you're going to have to remember. They're very basic rules, and so they're not like impossible to remember, but they're definitely there. Okay, it's kind of like the rule about when, oh, we don't need to go into that. Okay, so what you're going to do when dividing radicals, you're going to express as fractions. Okay, you're going to express it as fractions. That's a fancy way of saying write it as a fraction. Okay, all right, example. And of course, remember the very first example is one of the easiest ones. Okay, so I know you're going to get excited when you see this, but there's more coming. All right, so radical 40 divided by radical 5. We're going to rewrite this or express it as a fraction. Watch this. So we're going to have radical 40, and yes, I like saying it that way, over radical 5. Okay? Let's go ahead and take away the radical sign, make it as one big radical sign. What is 40 divided by 5? 8. So you have radical 8. Now you simplify. What that means is do the factor tree. 4 times 2, 2 times 2. So then I have 2 times 2 times 2. What is the root? Root is 2. So I'm going to circle my groups of 2. That group of 2, remember what happens with that? It goes on the outside, and the one left over goes on the inside. And there you're done. Okay, so look back over that and see if you understand what I just did. Okay? So we took it. Make sure, because this is being divided by this, so this goes on top. Put it all under one radical sign. I mean, yeah, you need to. I mean, you can do it both ways, I think, personally. But put all under one radical, divide, and you get this. Simplify, and you get that. Okay? All right. Your book has you putting it all under one radical sign. Okay, I'll just put it to you that way. Me, personally, I'm like, why can't you just divide these two and you get this and then simplify? They have reasons, because wait till you see the next one. And you'll see why I'm like, it is what it is. So put it all under one radical sign. Let's do another. All right. If we have 15, radical 15 over radical 12, put it all under one. Now we reduce those fractions, or that fraction. 3 goes, remember we can divide by 3. So 15 divided by 3, don't forget that radical sign, is 5. 12 divided by 3 is 4. Okay, now, unlike up here, where you can just divide evenly, 40 divided by 5 gives you 8. So we're done after we simplify. We can't do that here. You can't do 5 divided by 4. So then we have to change that. We now put it back in separate. We separate them right here. Notice this is a perfect square. So what is the square root of 4? 2. This is not a perfect square, so it stays the same. And there's no way to simplify this anymore, so this is your answer. Okay, so look back here. Put it all under 1. We went ahead and reduced or simplified the fraction. In fact, I'll write that here. Simplify fraction. Okay, reduce it. You get this. Can we divide 5 by 4? No. So then we go ahead and put it back with radical on the top and radical on the bottom. Now you can notice, oh look, I can work with this. That's a perfect square. It's 2. There's nothing you can do about that 5 and under the square root there, so you leave it. Okay? Now there's some rules you need to remember. You cannot have a radical in the denominator. That is one of the big rules, guys. It's considered not simplified. Okay? See, like, look right here. See that 4 had the radical sign? And we got rid of it. No radical. You cannot have a radical sign in the denominator, so you got to get rid of it. In this case, that was a perfect square, so we were able to get rid of it real easily. So I'm going to give you an example. No, you cannot have a radical sign as a denominator. No, 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 no. Again, we were able to get rid of that one right there because it was a perfect square. But sometimes it's not going to be a perfect square, so I'm about to show you how to get rid of that. One more rule. You cannot have a fraction as a radicand. That's that number inside the radical sign in your answer. You cannot have your answer like this right here cannot be your answer. You can't have a fraction under here. That's why you got to take it out. That's why I'm like, because you have to put it all underneath and then you have to take it out. So there's a lot of steps involved, but just remember your answer cannot look like this. That's just part of the process of getting to this step. So for example, this cannot happen. No. You cannot have a fraction as your answer under the radical sign. Okay. So again, you may want to use these notes while you're doing your homework because of the rules. All right. if you have a radicand, that's that number under the radical sign, as a denominator. Remember, you can't have it as a denominator. You multiply. Okay, so let me back up. Remember here we had 4, radical 4, okay, as a denominator. And I said you can't have that. Well, this was a perfect square, so we're able to just make it 2. But if it looked like this, where that is not a perfect square, this is what I'm telling you how to get rid of that radical 3. You're going to multiply everything by its equal, mainly by itself. This is just, your book has funny ways of telling you what to do. In other words, multiply, this is Miss Rogers' explanation, multiply top and bottom by itself. Okay? So if you have a radicand as a denominator, multiply everything by its equal, blah, 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 multiply top and bottom by itself. Okay? That's Mrs. Rogers' explanation. So, for example, okay, this, no, radical in denominator, no, 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 no. The first step, when you get a problem like this, you ask, can they be, oh, there's no space there, divided evenly? Can these two be divided evenly? Can 5 be divided by 7 evenly? Like this. Can 40 be divided by 5 evenly? Yep. So we were able to work it. Hold on. Dan? Oops, sorry. There's someone at my door. Okay, I'm back. Sorry, guys. I hate it when I have to answer the door in the middle of teaching. Okay, so anyway, let's go back to where we were. All right, here's an example. And the first question you ask is, can they be divided evenly? I don't remember what I was doing before I got interrupted and had to pause the video. But what that's asking is, can the two numbers be divided evenly like this? Okay? The answer to that is no. 5 cannot be divided evenly by 7. All right, so the second question you ask, can the fraction be simplified? Can it be simplified? Okay, that's like the second one that we just did. With 15 over 12, put it under there, we simplified it, and then we went on. Okay, that's what that second question is. Can it be simplified? So can this be simplified? No. All right, so here we go. I'm going to rewrite it right here. Okay, remember, you cannot have a radical in the denominator. So to get rid of that, we're going to multiply top and bottom by itself. We're multiplying the top and the bottom by the thing we want to get rid of. Okay? So, radical 5 times radical 7, radical 35. This times this gives you radical 49. Now, if you look, the square root of 49, what is the square root of 49? That is a perfect square. So, square root of 49 is 7. and radical 35 is over that. Can this be simplified anymore? Well, let's see. That's just 7 times 5. Those are both prime numbers. You can't take out any pair or anything, you know, with the root of 2. So therefore, this is as simplified as it's going to get. There's no more radical in denominator. Okay, so this is your answer. It's just like right here. Okay, but you got to make sure that the top number is simplified as far as it can go. Of course, this is a prime number, so you can just leave it like that. There's no radical sign on the denominator, so it's good to go. Same with this. There's you cannot simplify this any further, so you leave it alone. There's no radical sign in the denominator, so you leave it alone, and that's your answer. Let's do another one. Radical 3 divided by radical 6. Okay, remember the first step is you turn it into a fraction. So we're going to put the radical 3 on top and radical 6 on the bottom. We put it all under one radical sign. And remember, we simplify it if we can. Remember the first thing, can they be divided evenly? Can 3 be divided by 6 evenly? No, it cannot. 3 cannot be divided by 6 evenly. Step 2, can the fraction be simplified? Yes, it can. So we're going to simplify. Simplify that fraction to be 1/2. Okay, now, is there anything else that we can do with this? No, so then we're going to separate it again by the radical sign. Is this a perfect square? No, it's not. Can we have a radical sign in the denominator? No, you cannot. No radical sign, no radical in denominator. So what did I tell you? How do you get rid of that? Multiply the top and the bottom by itself. So radical 1 times radical 2, radical 2. Radical 2 times radical 2, radical 4. Oh my goodness. We have a perfect square. Right? So, square root of 2. What's square root of 4? Just plain old 2. And that's your answer. Because that 2 is prime. You cannot do anything else to it. Notice there is no radical sign in the denominator. So there you go. If you need to rewind some of these, you certainly can. All right. Next one. Okay. Radical 2 over radical 75. All right, this one's going to be a little different. We're not going to just, multiply this by itself on top and bottom, because this can be simplified. So watch this. If over here I do a factor tree for 75, you can do 25 times 3, that's prime, and then 5 times 5. So that's 3 times 5 times 5, right? Okay, the root, what's the root here? Root is 2. There's nothing there. So I'm circling my pair, and this is left over. So watch this. I'm bringing over my 2, and I'm writing this down here. 5 goes on the outside, 3 goes on the inside. So if you need to rewind that, you can check it out again. That's a big number that needs to be simplified. So I do my factor tree, root of 2, circle my pair, that 5 goes on the outside, that leftover 3 goes on the inside. That is carried over. Okay, I have a radical sign here. Can I have a radical sign? Nope. So I'm going to rewrite it down here and show you what you do. You got to get rid of that radical sign. So how do you get rid of it? Radical 3, radical 3. You're multiplying. So radical 2 times radical 3. And yes, that's how I say it, radical. All right. Radical 3 times radical 3. Notice I just brought over that 5. And that 3 times 3 is 9. What is that 9? That 9 is a perfect square. Right? Okay, so what is the square root of 9? 3. And what is 5 doing? It's 5 times square root of 9. So that is 5 times 3, because that 9, that's a perfect square. So the square root of 9 is 3. See how I'm multiplying that 5 times that? You get radical 6, or the square root of 6, if you want to call it that. 5 times 3 is 15. Now, this is simplified because look over here. If I did the little tree here, I have no pairs. So we leave that 6 alone. You need to, if I'm talking too fast and you need to redo this part of the video, you can to see step by step. That you got to do the factor tree. That gives you that down there. So then I rewrote it, and we just want to get rid of that square root of 3, so I multiply top and bottom with that. I bring over the 5. 3 times 3 is 9. 2 times 3 is 6. That 9's a perfect square. So see, 5 times 3, because square root of 9 is 3. I get 15, and that 6 we can't do anything with. All right, so let's open up your book to page 449. Let's look at number 1. Square root of 4 over square root of 25. Guys, this is easy. That's a perfect square. What's square root of 4? 2. What's square root of 25? 5. Hey, there's no more radical signs. You don't need to simplify this. It's already simplified. You're done. Those are good. 3. I had the square root of 5 divided by square root of 4. Rewrite it as a fraction. Oh, look, I don't even have to put it as a big old thing because, oh, look, there's a perfect square. Always look for those perfect squares. Those are so nice. So then that would just stay square root of 5, and the square root of 4 is 2. You're done. Because you can't simplify a prime number. And there's no radical sign in the denominator. So you're done. No more simplifying. 5. Square root of 8 over square root of 4. Okay, now watch this. Yes, that's a perfect square. But remember the very first question. Can they be divided evenly? Yes, they can. Look at this. 8 divided by 4, 2. You're done. Okay, be careful with that. All right, because, I mean, in reality, let me show you. If you had done it a different way, and I'm going to do this in red. Let's say this was 8 over 4. That's a perfect square, yes? Okay, so then you're left with the square root of 8 over 2. Is this simplified? Let's do the tree. 4 times 2. 2 times 2. So I have 2 times 2 times 2. What's my root? It's 2. So I can circle that. So then I'm left with, that goes on the outside, that goes on the inside, and that 2's down there. See where I'm going with this? 2 divided by 2 is 1. So you're left with that. See? They're the same. So that's 2 ways of doing that same problem. Okay, if y'all need to rewind that, you can. But if you go by that rule, step 1 is, can they be divided evenly? That saves you a whole lot of steps, doesn't it? So that's a lot better. But technically, you could do it this way. Separate them like this. Take that perfect square out. Make sure you simplify that 8 and rewrite it over 2, and then you can divide it. Either way, because there's going to be some of these you will be doing that. But if you don't have to, then why do it, right? Okay. 7. I have square root of 10 over 3 times square root of 5. Okay, so check this out. What is step 1 again? Can they be evenly divided? If I cover up that 3, can those 2 be evenly divided? Yes, they can. So the square root of 10 divided by square root of 5, square root of 2. And that 3, you just leave that 3 there. So make sure you do not forget that 3 there. Again, look to see if they can be evenly divided. It'll make your life a lot easier. In this point, they can. You just bring over that 3. All right, let's look at 9. 3 over square root of 13. Oh, man. There's no dividing. There's no simplifying. There's no nothing. Can you have a square root in the bottom? No, you cannot. So we got to get rid of it. And you do that by multiplying top and bottom by itself, by that square root. 3 times the square root of 13. 3 times square root of 13. Square root of 13 times square root of 13. Square root of 169. This is a perfect square. You're going to get to a point where you're going to see it's just going to be 13. So then you have 3 times square root of 13 over 13, because the square root of 169 is 13, because 13 times 13 is that, right? Okay, there's nothing else to do. 3 cannot be divided with 13. And just because this is 13, 13, you can't divide those, because with that radical sign over it, it's something completely different. So you can't do like 13 divided by 13 is 1 and call it good. They're 2 completely different things. So you're done. There's no more simplifying here with this or anything else. It's done. All right, I got 3 more examples for you. 11. 1 over the square root of 6. All right, guys, what can I do here? Cannot divide, cannot simplify. Even that 6, if I were to do a factor tree, is just 2 and 3. There's no pairs or anything. So what do? Can we have a radical sign in the denominator? No. So we are multiplying top and bottom by that weird radical. 1 times the square root of 6. It's just a square root of 6, because 1 times anything is anything. 6 times 6, it's radical, or our square root of 36. All right, this is a perfect square now. I got to keep reminding y'all that. Perfect square. Okay, so then I get that over 6. You cannot divide those anymore because they're two completely different things because of that radical sign. So you are done. There's no simplifying that because, again, look at the factor tree. It's just 2 times 3. There's no pairs. So can't simplify it anymore. It stays the way it is. 13. I have the square root of 14 divided by the square root of 21. Put them as a fraction, so I have square root of 14 over square root of 21. Okay, one of the questions, can it be simplified? Yes, it can. We could even put it like this. You can divide by 7. Oops, I should have not done that. I've skipped a step, sorry. Okay, so I'm putting it all under that. Now I'm going to simplify it, reduce it, and I get 2 over 3. Now, is there anything else I can do to this? Simplify it. No, you cannot have an answer that is a fraction of the radical, so that's when we separate it. Okay? Now, can I have a radical in the denominator? No. I'm sorry, I got distracted. So I multiply top and bottom by that. 2 times 3, square root of 6. Square root of 3 times square root of 3, square root of 9. Ooh, perfect square. So I get 6 on top, and the square root of 9 is 3. And that's it. You can't divide the square root of 6 by 3 because they're completely different things because of that radical sign. So you're done. And again, we can't simplify that. Last one, number 15. 3 times square root of 5 over square root of 15. Okay. Now, this is weird. We can, remember, reduce these things, right? Just just like dividing, you can reduce this thing. So 5 can be divided by 5 on both ends. So we get 3 on top over square root of 3 on the bottom. Okay, it's like that reverse division. Kind of like, let's see, where is it? Like this right here. See how we went up? Square root of 8 divided by square root of 4 is square root of 2. Well, here we're going to do the same thing. This would equal 1. Well, we don't need to put 1 there. 5 goes into 15 3 times. Okay? So can this be changed anymore? Well, can we have the radical sign in the denominator? No, we cannot. So I'm going to multiply top and bottom by that. 3 times the square root of 3 is just that. It's 3 times square root of 3. Square root of 3 times square root of 3, square root of 9. Oh, look, perfect square. So what's the square root of 9? It's 3. Are we done yet? Oh no, that's a regular 3 and that's a regular 3. So 3 divided by 3 is 1. So basically they kind of cross out. Because 3 divided by 3 is 1. If you wanted to put a 1 there, like that, that's okay. But this would be your answer. That right there, that radical is left over. Okay? 15 is like at the very bottom of all the work that you have to do, so that's why it's a weird problem. I think y'all ready? So I'm going to go ahead and set you free. You are doing page 449. You're doing numbers 2 through 16 even. think, let's see, 1, 2, 3, 4, 5, 6, 7, 8. That's 8 problems. I think you can handle it. It is due Monday, not Monday at midnight. I like for it to be Monday, like before 8 p.m. if possible, or just get it done today. All right. Also keep in mind, on Monday you have a quiz, and your IXL is due Monday. All right. So get to work. Use today to get it all done so you don't have to, deal with it over the weekend. All right? Take care, guys. If you have any questions on this, please contact me. And that's another thing. If y'all get it done and turned into me like early, then if I see serious problems, I can return it to you and say, hey, you need to make some corrections. But if you give it to me Monday night, like at 8 or 10 o'clock at night, then I'm grading it the next day, and then it's going to be late. So if you turn it into me at a decent time, then I can look over it even better. And I'm not saying if you miss 1, 2, or something like that, but if you're getting them all wrong or you're having major issues, I can let you know ahead of time. But that's only if you turn it in early. Otherwise, I'm grading it as is. Okay, guys? So ask me if you have any questions, need help. If you're like, man, I don't even know if I'm doing this right. Some of you have been doing really good. Y'all been like sending me sometimes 1 or 2 problems or answers and say, Miss Rogers, am I even on the right track? And I will help you. I will tell you, yes, you are, or no, you're not, and we'll get you on track, okay? All right, guys, have a great weekend, and I will talk to you later.